All right, here's the next sample problem I'm going to do. Depending on the packet and the year you're watching this, it may be on page 28 of your packet, number 3. It may not be. If you need to, pause the video now and you can copy down the prompt here so you have it if you can't find it on a handout. All right, so what we're going to do is we're going to read the prompt first and we're going to highlight the information and kind of dissect it so we know what's what. A pith ball has a charge of 5.4 times 10 to the minus 6 Coulomb. So that is Q. Q is charge. We'll call it Q1 since it's the first one we saw. The pith ball feels a force of 7 newtons. So that's the electrostatic force. That is our Fe. When it is held 0.3 meters away, that is going to be our distance. That is D. From a Van de Graaff generator, that's the big metal ball that shocks you. How many electrons? How many electrons? So this is not the charge. A lot of students mess this up and say this is the charge. This is N. This is the number of electrons. How many electrons must the Van de Graaff generator have in order for this to happen? Okay, so I've written our 2 equations here. And I don't know which one I'm going to use, if I'm going to use both or I'm just going to use one yet. But what we're going to do is let's kind of take an inventory of what we have. So the pith ball has a charge, so I called that Q1, so I have Q1. Oh, and I also have K, that's a constant. The pith ball feels a force, that's Fe, so I got that. When it is held a distance, okay, we have D, away from the Van de Graaff. How many electrons? So many students mess up and they think this goes together. Nope, 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 those do not go together. The number, how many, is N over here in this other equation, okay? How many electrons must the Van de Graaff generator have in order for this to happen? E is a constant. It's just the amount of charge for every particle, for every electron or every proton. And so it looks like here, what am I trying to find? How many electrons? I'm trying to find this N here. Now, the question is this Q here the same as that one? Are they the same? Now, how do we figure that out? Well, let's draw a picture. I think that would help. So we have the pith ball, which is a tiny little one. That has Q1 on it. So the pith ball's there. And we know the force on the pith ball. And we know the distance between it and the big Van de Graaff generator. And we want to know how many electrons, okay, this is going to be harder, must the Van de Graaff generator have? So we want to know how many extra electrons. So N equals what for over here? So while you may be tempted to say, oh, I have Q, and I want to find N, I can plug them in and I'm done, the picture tells us that's not true. The charge we're given is over here for the pith ball, but we want to know the number of electrons over on the Van de Graaff generator. So this is going to be a 2-step problem. Our final goal is to get this, but we're going to need to find the charge. So let's make a note over here. We need to know Q2. Q2 equals what? So let's label that in our equation here. That's Q2. So first step is we're going to find Q2, and then we're going to plug it in over here. All right. What I'm going to do here is I am going to, before I plug everything into this equation, I'm going to actually solve this equation in variables for Q2. I think it's easier to do it that way because then you only have to punch things in on the calculator. So many students, when I ask them, well, what did you mess up? They said, well, for the calculator, I did too many steps. I did this times this, and I hit equals. And then I had to copy that down. And then I did this times this, and I hit equals. And it's just, there's just too much room for error. So let's write this equation here, and then we'll solve it for Q2. We're going to solve for Q2. So, how quickly you do this, some students will be able to do this in their head. Others want to do one variable at a time. Some will do multiple variables at a time. If I want to solve for Q2, let's get rid of that d squared first. So I'm going to multiply both sides by d squared. So let's write this in red. Try to keep the color coding nice. Fe times d squared. I guess the order doesn't matter. 3 times 2 is the same thing as 2 times 3. So I'm just write Fe times d squared equals K Q1 times Q2. Now remember, I'm solving for that Q2. Okay. Keep our eye on the prize. Let's make this a different color. That's what we're going for here. So to solve for Q2, I need to get rid of K and Q1. So what I'm going to do is I'm going to divide both sides by K times Q1. Divide both sides by K times Q1. So that K times Q1 divided by K times Q1 is just 1. And so my left-hand side becomes Fe times D squared over K times Q1 equals Q2, which is what I want, my first step. Okay. If you want, you can plug in all your numbers here and then solve it. I think it's more difficult. But as long as you show your work and you can get the correct answer in the end, it doesn't matter. All right, so what we're going to do now is we're going to plug in some values here. So I got to plug in my Fe, and this is where doing this annotation is really, really helpful because I don't have to rethink the problem. I just look up here and say, oh, there's my Fe, copy that number. There's my D, they copy that number. You can also make a list on the side if you want as well. So let's just plug in some numbers here. Let's get this out of the way. So Fe is 7 newtons. My K is, D squared is 0.03. 0.03 squared. Oops, and I wrote equals there. My bad. So I'm just using this equation. So Fe times D squared. Then I got to divide by K. Divide by K, so that's 9 times 10 to the 9th. And then I have a Q1 in there. 5.4 times 10 to the minus 6. 5.4 times 10 to the minus 6 equals Q2. So now you have one step on your calculator. Just one step. So plug that into your calculator, pause the video, plug it into your calculator, and then come back and see what answer you get for Q2. And that's what I got there. However, we're not done because we asked how many electrons. Biggest mistake on this problem is the students circle this answer and they say they're done. We want to know how many. So remember, this was step 1 where we did step 1. Now we got to go and do step 2. So I'm going to take this number and plug it into this equation. So I have Q equals NE. So Q is 1.296. If you round it to like 1.3, that's fine. Times 10 to the minus 7 equals N, what I'm looking for, times 1.6 times 10 to the minus 19. Yeah. And then I'm going to divide both sides. I'm solving for N, so divide both sides by 1.6 times 10 to the minus 19. Sorry, my stylus is probably really loud this whole time. And we're going to get a value of N. Now, if you're using your own calculator, you have to put this in parentheses when you divide. Otherwise, it'll divide by 1.6 and then it'll multiply by times 10 to the minus 19. So whenever you get a number that's like way, way off by scientific notation, it's probably a parentheses issue. 8.1 times 10 to the 11 electrons. So that is my answer. How many electrons must the Van de Graaff generator have? How many extra electrons? It must have this many extra electrons. All right, and that's how you do it.